we're going to go over the test first, and let me share that screen for you. Okay, so because the test order was randomized, the questions were randomized. It may be in a different order that you have on your screen or on your paper here in class. So for this question, which of the following graphs could represent a coloring map of the 6 states pictured below? Obviously, this first one is completely incorrect. You don't need to connect them all. You only connect vertices if they share a border. The correct answer is this one right here. The one that does not have Utah and New Mexico connected. Remember that that Utah and New Mexico don't actually share a border. They just meet at that point, at that four corners point. So they don't actually share a border. Each of these questions was 6 points apiece. Who left? Yeah. Next question. Suppose that you want to draw a graph for this floor plan or this apartment or a house, whatever this is. I didn't go over anything like this. You're supposed to use what you guys know about graphs, and it specifically says which rooms are adjoined with the doorway. So which of the following would best represent the vertices in the graph? Well, each room would likely be a vertex, and if we wanted to connect them, we would connect them if they had a doorway between them. So I would connect those two, I would connect those two, and so on. So if they had a doorway between them, I would connect them with an edge, but the correct answer would be the rooms would be the vertices. Next. The Knights Tour. This is a game that I wish we would have played. We play it every year in this class. Unfortunately, because of COVID, we couldn't do that this year. But this is an example of a Hamiltonian path. Because you're visiting every square exactly once. So Hamiltonian path was the correct answer for this one. Next question, which of the following is an example of a spanning tree? This is a question that was almost like 98% correct. The correct answer is this one right here. This one is a tree because it does not have any cycles. Next question. What is the shortest path between vertex C and H? You had two parts to this question. You had to tell me the path and you had to tell me the weight. So C to D, D to E, E to G, G to H is the shortest path. That is 11. The weight is 11. So you had to write 11 and you had to write those sequence of vertices in order to get full credits. Some of you got partial credit because you got one or you added it up wrong. So you might have got partial credit on that. The next question. This is the one question where if you were to say, hey, is there a trick question on this test? I would say this one might have been a trick question. This one says vertices A, B, E, and F create a cycle. And a lot of you guys thought maybe, well, if I go in that order, no, it doesn't create a cycle. But that's not what it's asking you. It's just asking you if those four do create a cycle. And yeah, they do. You could literally just go all the way around. So the correct answer is true on that question. A couple people did ask, hey, does it need to be in that order? And I said, does it say that? And you're like, okay, got it. All right. Next, this question, let me clear the screen. I didn't clear that. Edges in a graph generally represent which of the following? And the correct answer is roads and paths. Intersections, landmarks, and cities are all vertices. So roads and paths is going to be the correct answer there. Next, let's do this. In the vertex above, vertex H has a degree of, and the correct answer is 5. 1, 2, 3, 4, 5 edges intersected. I had somebody put like 120 degrees. This isn't geometry, guys. We've talked about that. This is not geometry. If you put 120 degrees, you're kind of not knowing what we're doing in this class then. Which type of graph can always be colored with two colors? This is directly from the notes. It is both A and B. Graphs in the shape of an even-sided polygon and spanning trees can always be colored in two colors. All right. This question is the one where you had to take a picture and send it to me. There were a lot of people who got full credit. This was worth 10 points because it was two parts. But there were also a lot of people that didn't understand or probably didn't realize what they were supposed to be doing. It doesn't tell you that you have to use a minimum spanning tree, but that's exactly what you should have been doing. You should have put all the numbers in order from least to greatest and so forth, and started connecting them, starting with the lowest one. Cross it off the list, go to the next one. Connect it next one as long as it doesn't create a cycle. Cross it off the list. This is what your spanning tree should have looked like if you did it correctly. There's two twos. There were several, I don't think in this class, but in later classes, people that had the correct answer in terms of like the way the graph was supposed to look, but with no numbers and no work. So if you submitted a problem with no numbers and no work and no answer to part two, then you didn't get credit. I'm sorry. I have a feeling there was pictures floating around out there, but if you didn't show your work by crossing off numbers or even labeling this, then you did not get credit for this problem. I'm sorry. If you made one mistake, you got 3 points off, so you got 7 points out of 10. There's some other partial credits depending on whether you answered this question or not. If you added them all up, the minimum weight was 17. So no, the school doesn't have enough power cores. They'd have to go buy some more because they would only have 16. All right, next question. Almost done here. Vertex D and vertex H can be colored using the same colors. Here's D and vertex D and vertex F. Here's D, here's F. Yes, they can be colored using the same color. They do not share an edge. Even though this edge is all the way straight, it goes through another vertex. So that can be colored using the same color. Number 12, explain how Eulerian circuits, Hamiltonian circuits, and cycles are all similar. They all start and end at the same vertex. They all start and end at the same vertex. That's the simplest explanation. A vertex cannot have more than one edge intersecting it. That is false. It obviously can have a lot more edges intersecting it. What is the chromatic number of this graph? There are a couple of ways you could color this. There's one color there. There's another color there. You could do another color here. A few different ways. The chromatic number is 3 because I can use it in 3 colors. There's no way to do this one in 2 colors. No way to do it on 2 colors. A custodian waxing the floors in every hallway, trying to backtrack as little as possible, is a real life example of a Eulerian circuit. If you guys are if you're a custodian and you're trying to wax all the hallways are going to be edges. You try not to backtrack. When you clean in the hallways, you don't want to go back down the same hallway. So that is a Eulerian circuit. And last but not least, select all that apply on this particular graph. If I go through and label all the degrees of every vertex, I quickly realize that all the degrees are even. So this has a Eulerian path and a Eulerian circuit. And if I wanted to find a Hamiltonian, I could literally just go all the way around the outside. This has a Hamiltonian path and a Hamiltonian circuit. You should have put all 4 of them. We got partial credit if you just picked a couple of them. Any questions on your test? All right. So if you guys want to retest, this is for anybody. If you want to take a retest, you'll have to do it next week. You'll need to schedule an appointment with me by sending me an email or a message on Schoology. And it's got to be during Lobo time or advisory, either one. There should be plenty of different options for you guys to retake your test. Okay. Oh, I got a phone call. Hold on a second. Okay, so this is where we left off on Wednesday, where we finished, I think, question 17. Correct me if I'm wrong, or if we got a little bit farther than this, let me know, guys. Let's just recap really quick before we move on. what we're talking about with these project management stuff. Okay. Jimmy, you with us? Jimmy. Jimmy. I can't hear anything. Yeah, that's fine. We get on Wednesday. You have that too loud, dude. If you can't, you have that too loud if you can't even hear me. So let's just recap. And I'll use you guys in the class right now to help me out. Tell me which activities can start right away on this project right here. A, B, C, why? They're connected to start, okay? Luke wasn't even here on Wednesday. He could figure that one out, right? Yeah. They're connected to start. What about somebody at home? Let me get somebody at home. Somebody at home, tell me what is a prerequisite for activity D? Destiny, what's the prerequisite for activity D? So C is one. What's the other one? B is the other one. So I hope you guys are there with me. Activity D has two prerequisites. It has to wait for C and for B to finish. Which one finishes earlier, B or C?
D or C?
B or C?
Oh, B or C?
Yeah, B finishes earlier. We can see from our timeline that we created on Wednesday that B finishes after 2 hours because it only takes 2 weeks, I should say, 2 weeks. But C finishes after 6 weeks. So after 6 weeks, then D can start. Even though B finishes earlier, D cannot start until both of them are done. Okay, so C will not start, or D will not start until week 6 when C finishes. The way that we created this timeline, we kept following that particular mentality. So looking forward, where I'm looking at J had to wait for both E or F and D to finish. Well, D finished first, but F didn't finish over here till 14. So that's why J couldn't start until at least week 14, and so on. Okay, and this is how we created. If you weren't here on Wednesday or you don't remember, this is how we created this timeline. So let's talk about the answers on page number 4, number 18 through 23. Did we go over those on Wednesday, Christiana?
No, we didn't get to it.
We didn't get to those questions. Okay, so let's talk about those questions. We should be able to answer these questions pretty quickly now that we've already created the timeline. Okay, so now that we've already created the timeline. Jimmy, what are you working on? What are you working on?
Old work.
No, do this right now. So you're caught up for right now. Do you have that packet?
Yeah.
Okay, do that right now. Then do old work when we're done with this. That's not it. That's the project I just gave you.
Then I don't have it.
So you're not here on Wednesday?
No, I wasn't.
You were?
I wasn't.
Oh, well, you need to go watch the lesson too. Okay. 18 says determine the minimum time needed to complete the project. Can't we already answer that question based on our timeline? Christiana, what's the minimum time needed?
The minimum time of like the whole thing?
Yeah.
21.
21 hours. Okay. We ended over here and we call it the minimum time. So this is the question number 18. Okay. We call this the minimum time because can you complete this project in any less time than that? No, we have to have at least 21 hours. That's why it's the minimum time to complete it. We can complete it in longer if we wanted to, if we stretch things out, but we can't complete it any less time than 21 hours. Okay. Now, next question says, which activities are critical activities? This one, we probably want to go back to the chart to try to figure out the critical activities. I need to try to find the longest path in this chart. Was anybody at home or here able to find the longest path in this chart? We know the longest path has to equal to 21. Let me call on somebody at home. Sonny, were you able to find the longest path? Zuriel, did you find it? B to G to finish, that's the shortest path. What about the longest path? You find it, Christiana? Okay, so C to E to F to J to K. Careful. It's actually going to be to H to K because that's 2 plus 5. All right. Remember, it has to add up to 21. And if you would have added up the ones with J, it would have only added up to 20. Okay. So this is the longest path. So the answer to question number 19 says, what are the critical activities? The critical activities are C, E, F, H, and K. Why are they critical? Why do we call them critical again? What happens if I delay these critical activities? It sucks when you guys are behind and don't understand because you didn't watch a lesson when you're absent. Okay, this is just the way it's going to be. You miss a class, you got to watch the lesson. There's a whole reason I record them and put them up there for you guys. Jared said takes the longest amount of time. Yeah, so they're critical because if I delay these, I delay the whole project. Okay, if any one of these activities on that path gets delayed, it's going to go past 21 weeks. Okay, some of these other ones I can delay, but I can't delay these. These delay my entire project. Okay, if I'm getting paid to run this project and I only get paid by the project, I don't want to delay that because I want to make up time. I want to do it as fast as I can. Luke already answered number 20. 20 says, which activities do not have prerequisites? Which ones are they? A, B, and C. A, B, and C don't have prerequisites. They're connected to start. Uh, 21. 21 says, how many weeks can activity G be delayed without affecting the overall completion time? Well, look at G. Does anything have to wait on G to finish? No. Once G starts, and we know G can start right after B, which is right over here. That's why it's on the timeline. Once G starts at 2, it's going to end at 9. Nothing is waiting on G. Absolutely nothing, according to the chart. There's nothing waiting on G over here, okay? And we know the project's going to end at 21 hours. We know that it's going to end at 21 hours. So we have all this big gap right here that we could shift this over if we really wanted to. How do I figure out how long it is that I can delay that? If this is 21 weeks, and this is 9 weeks, how long can I delay that? What do I calculate? 21 minus, yeah, just subtract this number from the total. So 21 minus 9 is 12 weeks. Good. Yeah, this one was an easy one. We could actually delay a couple of those other non-critical activities, but I gave you the easy one to figure out because nothing had to wait on G. Nothing had to wait on G in order to be finished. 22 and 23, you can answer strictly from just looking at the timeline. 22 says, after how many weeks is the earliest that H could start? Well, H is right here. We set it up that way because it can't start any earlier than that. So what's the answer to number 22? 14 weeks. Okay. H can't start any earlier than 14 weeks. And number 23, after how many weeks is the earliest that E could finish? No, E could finish.
Oh, finish?
Yeah. 11. Yeah. E can't finish any earlier than that. All these could start and end later, right? We're talking about what's the earliest. And it can't do any earlier than that. All right. Any questions on 1 through 23 so far? Okay, so now you guys are going to practice writing. What was 23? 23 was 11 weeks. E can't finish any earlier than this. Right there. Now you guys are going to practice drawing your own. Okay, drawing your own. Thanks, Carlos. Drawing your own classes. PERT chart, I should say. Let me give you a little background, and I'm going to pause the video and give you guys a chance to draw it because it doesn't take more than a couple of minutes to actually do it. So this next section talks about scheduling classes in college. It can be very similar. Over 4 years, there are certain classes you must take, and many classes have prerequisites. I can't tell you how many times teaching seniors over the years that a senior comes in and at halfway through the first semester, or maybe at the end of the first semester, they realize they haven't taken something that they need to graduate, right? And sometimes those classes have prerequisites. You can't take AQR without taking Algebra 2. You can't take a second foreign language without taking a first foreign language. And you need 2 foreign languages if you want to graduate on the distinguished plan, right? So what happens when you get to senior year and you haven't taken a foreign language at all yet? Well, now you're screwed, right? So this happens, and it's important to plan out your schedule. This happens in college too. Suppose you're starting your junior year, which is your 3rd year in college, and you still need to take the following classes. You can see them on the screen. You can see them on your paper. A lot of them have prerequisites and some of them don't, and you need to take them before you can graduate. Each class is a semester long, so each class is just 1 semester. Okay, 1 semester. You're going to create a PERT chart for the remaining of classes. How do you think when we start this out, and I'm going to give you a few minutes to try to do it on your own. When you start this out, what's the first thing we need to put on our PERT chart? No, before that. What did all the other PERT charts that they gave you have? A start box, yeah. So everybody put a start box on their PERT chart for number 24. This is question number 24. And I'll help you get started. How do I know which classes can get started right away? Calculus 1, psychology, and speech, because they have no prerequisites. So those are the first 3 that get connected to start. I'm going to give you guys a couple minutes to see if you guys can keep going. I'm going to pause this video here so that people at home watching don't have to sit through the silence. Okay, so I think we should be able to see this pretty easy. If we're looking at Calculus 1, look at the list. When I see Calculus 1 as a prerequisite for both Calculus 2 and for Physics 1, that means I'm going to need to have 2 different arrows coming out of Calculus 1 pointing to those classes. So your next step will look probably something like that. Did you guys have that? Now again, looking down at there, Calculus 2 is a prerequisite for quantum mechanics, but I don't want to put that yet because I don't even have Physics 2 out here yet. So let me look at Physics 1, and I see Physics 1 is a prerequisite for Physics 2, right? Wait till we're done, real quick. We're almost done. So I need to have arrow coming out of physics 1 and going into physics 2. Now I have both of these classes down here. I have them both. They're here. They're prerequisites for quantum mechanics. So both of those should have arrows going into quantum mechanics. So you'll have something that looks like that. And I just use abbreviations on these as much as possible. What about psychology? Does psychology have any, is it a prerequisite for something else? No. So I'm done with that one. And then speech is a prerequisite we can see down here for argument and debate. So now I have all 8 of my classes up here, and I am almost done. What's the last thing I need to put on here? I had a start box. I have finish box. Now, anything that is not already pointing to something, so if it's at the end of its road, you point it to finish. Okay. Use this time, the next 10 minutes or so, answer the questions on the last page, 25 through 30. And let me know, and I'll check your work as you guys are going through. So we're talking about the critical classes. Remember, each one of these classes is only one semester. Okay, they're all one semester. So they all have a length of one, but we can still find the longest path, right? Which one's the longest path?
It's Calc 1 to
Calc.
to this 2.
Yeah, this is the longest path here. So those 4, I'm going to clear this. 1, 2, 3, 4. Those are the critical classes. If I delay those, I'm not graduating on time, right? That's the whole idea of this. You know, I'm not going to graduate on time if I delay these classes. So those are the critical classes. And how many semesters, if I stick to this plan, how many semesters will it take for me to graduate? How many more semesters, I should say? Well, each of these is a semester long. So it'll take me 1, 2, 3, 4 semesters. Yeah. Four semesters to graduate. So on 27, what you're doing is you're creating a schedule of classes that you can take. There's a lot of different ways you could set this up, but there's one thing for sure. Okay. So fall of your junior year, what do you for sure have to take? Calc 1. For your spring of your junior year, what do you for sure have to take? Physics 1. Your fall of your senior year, what do you for sure have to take? Physics 2. And then your spring or your senior year, you'll have to take quantum mechanics. If you don't take it in that order, on those for sure, you won't graduate on time. Now keep in mind some of the other ones can't take, like you can't take calculus 2 in your first semester because you have to wait to take calculus 1, right? So you'll have to take one of the other classes. Okay. All right. Just for the purposes of the recording here, guys, when you're done with this assignment, you can turn it in at home. You guys here can just show it to me. There is a quote unquote quiz for this in Google Classroom. I keep saying that. It's in Schoology, and it's 10 questions on there. It is untimed. That means that if you start it, you answer 2 questions, and then you leave it later. If you leave it, it'll leave where you left off. It won't penalize you. The whole point, it's labeled a quiz, but it's a lot easier to grade instead of a homework. So the idea is use your notes, work together if you really wanted to, but don't copy somebody. Make sure you understand it. That way, I want you to get the right answers, and we're going to go over the answers on Tuesday when I see you guys again. So you have between now and the beginning of class on Tuesday to finish it. Okay, but don't feel compelled like you have to finish it right away. There is no timer on it, and it won't lock you out if you leave and come back. Okay, so take your time on that.